I don't know if we could fear the same in programming. That this, if you want to do the correct, the good programming, that fewer and fewer want to do it because it's just taking much longer time.
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. All right, I am here today with Anders Sekanina. Anders has been part of our mastermind group for a few years, so I've gotten a chance to get to know him over the years. If you
Yeah.
haven't, you should get to know him. He's a great guy. I enjoy having him in our mastermind group. And actually, we have something else in common that I've only started to realize recently. I'm looking at the photo behind you. It's like the first thing I noticed. And yeah, it's ice climbing. And that is very pertinent because I am about to leave to go on an ice climbing trip this afternoon. So I thought that was really cool. Yeah, forget LabVIEW for a minute. How did you get started in climbing?
Oh yeah, I've always been doing outdoor activities. I was starting with some scouts, organization, and they're walking in the mountains. And I also with my parents a lot walking in the mountains, cross country skiing and stuff like that. And then like took as a continue for that, instead of only walking, then we can also climb a little. So I actually started with outdoor climbing as the first. Started rock climbing, and then when I have got thought rock climbing was something for me, then I started in climbing gym. We don't have so much rocks just outside in Denmark. We need to drive to Sweden. So for normal training, it's more inside. But then I started climbing in climbing gyms for training, and but did more and more. It's always been the outdoor climbing, and therefore it was natural with alpinism and ice climbing. It's my favorite. All long natural protected route where you set your own gears. Like when you're out, where not necessarily know which way to go, that you're a little out finding your own way. That's the most that's what I like most, definitely.
Yeah, I think there's a lot to be said. There's a lot of people in the LabVIEW community who are climbers. Jorg comes to mind. I think he's more of an indoor boulderer, but there's a bunch of other people. Derek Trepanier was always showing pictures of him out climbing, and there's some others as well. I think there's a couple interesting things that you can take from climbing. I think you hit on one, self-reliance. I think that's a very good one. I was reading a book called The Secrets of Consulting. Or no, sorry, the second book. So there's two books. There's The Secrets of Consulting, and then there's More Secrets of Consulting. And he had an interesting analogy. So in the second book, it was a list of like tools that he uses to like mental models to like help him through consulting gigs. And he used physical objects. And one of the things he used was a carabiner. And I thought that was quite interesting because basically he was like, when you're climbing, you place a carabiner, you clip the rope to it, and that limits the risk. So that then if you fall, like it's not as big a deal if you use the carabiners appropriately. And I thought that was really interesting. I'm curious if you have any thoughts on that.
Yes, there's of course the risk taking. That's also from all the projects I'm working on, and as a single person, a consultant. Especially outdoor climbing. With and alpine climbing, it's purely risk taking. Do I want to take this risk? What are the gain? What are the risk of that? And then of course there's all the nerdy stuff about protection and how to place it correct, and how to make the optimal things. That's also very engineer alike. So there is a lot of engineers, at least what I see in climbing. There is also other who have nothing with engineering, but there is a lot who are very engineering like.
Yeah, I think rock climbing in particular attracts engineers because there's lots of gadgets, the cams and the nuts and the pitons and the carabiners, and there's a lot of like physics involved. And
Yeah.
so it helps if you want to be a good rock climber. Well, there's like the gymnastic movement part of rock climbing, and like that part appeals more to like people who are really athletic. but the nerdy gear side definitely appeals to the engineers quite a bit, I think.
Yeah, and what is also it's more the coming out and have to focus and take the risk. I can feel with many of the climbing partners I've had when we are back in the climbing gym, they're much stronger than me. Definitely, I've never been so strong, especially not with bouldering. It's yeah, I've never been able to train up so strong. But then when we come out, and it's more having the maybe not the headness, but have like the focus, have the will to really go for it. Then I'm often the one taking the last part and ensure we are coming up when everybody else is saying, oh yeah, it's too much and it'll be a too long day and stuff like that. That I'm like pulling the last pitches up.
Yeah,
And I think it's a lot the same for the projects I'm in, that are maybe not necessarily the one that are the best technical for everything, but like taking the project what we have and get to the finish. That is my strength.
yeah, I feel like I'm similar. I am not a super strong climber, but I lead climb very close to my ability because I feel like I've gotten very good at managing the risk and bringing it down to an acceptable level. And honestly, I don't know, maybe I'm kind of crazy, but I like when I'm lead climbing to be like right on the edge. I like it when I feel that moment where I have that moment of panic and I'm like, oh my God, what am I doing? And then I like start breathing and calm down. I'm like, okay. And I look and I assess and I'm very methodical. I'm like, okay, well, I've got three pieces of gear between me and the ground. If I let go, what's the worst that's going to happen? And I think about all that and I get in my head and then I'm like, okay. There is a very interesting thing called I don't know if you've seen it, and they might not do it in Denmark, but the Rock Warrior's Way. There's a guy Arno Ilgner. It's worth looking up. He wrote a book. It's very good.
Yeah,
Yeah.
I don't remember it, but probably what was it about?
So he has a whole methodology, and I'm going to butcher it because it's been a while, but basically part of it was when you're resting, rest, and when you're climbing, climb. So like, be very clear and intentional. And it was a lot about assessing the risk. So you look at it and you say, okay, Dow, direction, angle, and obstacle. So you look at, okay, I'm going to fall. How far am I going to fall? Is it straight down? Am I going to pendulum? What's the angle? What's the actually it might be distance, angle, and obstacles, but how far am I going to fall? Is there anything I'm going to hit? Am I going to swing into a corner? Am I going to hit a ledge? And then it's about like engaging with the risk and like, okay, when you make the decision to climb, you climb and you forget about everything else because you've accepted the risk. You say, I'm okay with falling here. Therefore, you push it out of your head. Because sometimes like a lot of times when I fall climbing, I fall because I give up mentally and I let go. Very rarely do I fall because I slip and I just fall off. Right.
Yeah,
Sometimes,
yeah,
but
yeah,
like his kind of philosophy is you should go for the point where you fall off because you actually can't hold on and you slip or whatever, or like your grip just gives up. And you should not fall because, oh my God, I'm scared. I don't know what to do.
yeah,
Right.
yeah.
Yeah.
I agree. It's not always that easy, but it's right. Yes,
Yeah,
yes.
there's
But
another
it's
lesson.
when you then are coming in this mindset, then you can really push it. And it's all it's I'm easier doing it out in the long route.
Yeah. Well, another lesson too. So somebody else had talked about in programming, I've heard the thing like the smallest thing that could possibly work, but or the simplest thing that could possibly work, or how do we take a small step in the right direction? And he's about like engaging with the risk. Like, okay, if you don't feel comfortable, you can place another piece of gear. So now you've lowered the risk, or you can go up and maybe make one or two moves and try out the hold so that you know what you're doing. So you're also lowering the risk because now you know where the good holds are and you know what's possible. And I find like in programming, right, a lot of that, like I feel like to go back to the carabiner analogy, right, like the carabiners for me are like CI/CD and test-driven development and having a good set of tests and having that like safety net. And then like taking the small steps is like trying to break the problem down into as small as possible, particularly like refactoring, right? Like I want to make this big giant change and I could just break everything and start rewriting, but that's really risky, right? But I can engage with the risk by taking a small step, run the test. Oh, that passed. Take another small step, run the test. Does that make sense?
Definitely. Yeah, 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 yeah. It is. It is. Yeah, taking and then first take the most risky parts and work on them first, and then you know you can do the rest. Yeah.
Yeah, no, I'm very glad you put up that picture because that sparked a whole conversation that I don't think we. So I think that's cool.
I have I have just very messy things behind me because it's a small lab here, and I'm also doing electronic stuff. So I have equipment and a lot of things. So I think that would be too. Yeah.
It's interesting, right? Like some people are like super organized and everything's nice and neat. And for me, I'm interesting. I feel like when it comes to writing code, I'm very organized about how I structure the code and everything. But like my office is a mess. I've got books everywhere and like yeah. So I know that's something I struggle with. I had a friend who was really into a thing called Getting Things Done. I don't know if you've heard of that book. It's like a famous book for like productivity and stuff.
Yeah.
And yeah, I tried to do that and I did not succeed very well. But I have another friend now that I've been hanging out with who's really into it. So maybe I'll have to get back into trying to do that. I think the big thing I took away from Getting Things Done from reading it was part of it was that your working memory only holds so many things. And so a big part of it was trying to get things out of your head and get them written down somewhere.
Yeah.
So you don't constantly keep recycling them in your head and thinking about it. Like if you're constantly like in your head, remind yourself, oh, I got to do this later. I got to do this later. I got to do this later. That's taking up mental bandwidth that could be used for other things.
Yeah, and like written it down so you know you have it there, but then have one thing you're doing focused, finish that, and then step back and say, okay, what is the next? Instead of going forth and back to a lot of things.
My big problem with the writing things down is I'm good about writing things down, but I'm bad about putting them in a place where I'll find them. So I have a lot of post-it notes sitting everywhere. I'm like, oh, if I put this post-it note somewhere where I'll see it, I think, oh, I'll get to it, and then somehow it gets lost or I forget about it.
Yeah, I have when I have a lot to do, then I start to use some organized with to-do lists and stuff like that, putting it in. But then when I then have not so much to do it like fading out because then don't feel I need it more, and then because then it's easier to have and then it's coming back. I haven't really got to have it consistently. Even I think it would be good.
Tie this back into climbing though, I feel like there's a motivation part of it too, in the sense that when I'm really motivated, I can be really organized. Because when I was doing serious mountaineering, like I literally had a spreadsheet with every piece of gear I owned. I knew exactly how much it weighed, exactly how much space it took up, and I could like literally virtually pack my pack for a trip, and I would know exactly how much weight I had. I'd be like, oh, I'm like 2 ounces under. I can take an extra goo now or something. And I
Yeah,
don't know if you got to that level of like mania, but I definitely had that at one point.
yeah, in the beginning, but it's long time ago. No, not so much with gear, but I would say when I'm out there, it's about optimizing. It's
Yeah.
have as little spare time as possible because that is where I can save time. Maybe a little longer time in climbing the pitches, but if I can save with having very fast the rope ready and stuff like that. So it's about optimization, and it's also what trying to do in the programming world, like optimize the way you're doing the things. So the difficult part you can use more time on, but all the other things, general things, you're not spending time on.
Yeah, well, it's interesting. So, and here's another parallel to coding. I think in the beginning you learn rules, and you're very rules based, and you're very be, uh, like you learn rules like don't use global variables and all. So when you're climbing, you learn a set of specific rules, like yeah, oh, we always do it this way, always do it that way. And then as you get older, you learn some of the caveats and some of the like, oh, well, there's this other way to do it, and that's okay. And I feel like too, the better I get at improvising climbing, the less I care about, oh, I have to have exactly the right gear. Because also, like climbing, I think about like, you have an ice climbing picture in your background. You probably have really nice curved tools with nice handles on them and stuff. And like people used to climb with old straight shaft wooden tools that were really hard to hold on to and like, right? And
Yeah,
the crampons were really crappy and the boots were super flexible and wobbling all over. And people climbed really hard stuff. Some of them climbed harder stuff that I could climb now. And
that's
so
right, that's right. But yeah, it was also the best climbers, and the best climbers today is climbing way over that.
yeah,
But
well,
it's
that too. Yeah.
yeah. The gears have really done something. I can really feel different with having new boots,
Well, it's
new.
interesting, right? Because the tools do make a difference,
Yeah,
but the tools also let you get in over your head very easily if you're not careful, right? Like, for example, like the nice curved ice tools will let you climb really hard stuff. But particularly, I feel like, and maybe you've seen this in climbing now, and actually, maybe this is equivalent to like an AI type discussion. The climbing gym has accelerated and we had a conversation about this earlier. The climbing gym has accelerated how hard a thing you can climb, but it hasn't replaced the knowledge of how to climb outside safely, to know about like falling rock and how to place anchors and all this etiquette stuff and how to get down. And it sets people up for failure. I feel like AI is the same way. AI is like the climbing gym of coding. It lets you get really far in what you can code, but it doesn't give you the judgment that you need in order to figure out what you should do and how to do things securely and in a way that's maintainable. Does that?
Yes, it makes sense. And especially what I see is that fewer and fewer are then coming out and doing the rock climbing on a little sketchy rocks. And we have the closest rock climbing we have is in Sweden, and it's some very loose rocks and stuff like that. And in the zeros and in the 90s it was full every weekend, but now people don't want to climb there because they can't climb as hard as they're doing inside, and they don't want to take this learning about how to react when everything is not solid, and you will have to think about setting your protection, and you maybe need to go first a grade down or two. So this part of climbing, at least what I'm seeing, is decreasing. And I don't know if we could fear the same in programming, that this, if you want to do the good programming, that fewer and fewer want to do it because it's just taking much longer time.
Yeah. Well, the switch I see, and people do things for different reasons, and probably in coding as well, like you hit on. There are some people like doing web apps, some people like doing, like, I personally, when it comes to coding, I like things that touch real world physical things. Like I used to always tell myself I would never be a website or database programmer because you're like manipulating bits in the cloud, but like there's no real world thing that's changing, which is one of the things I like about LabVIEW. But I think for climbing, there's also, like, I get into climbing and I'm into climbing because I like the adventure part of it. I like the risk part of it. I like the risk management and all of that. And I think the people who end up climbing in climbing gyms and bouldering and doing some of the less risky parts of rock climbing, I think they like more the gymnastic movement part of it, which I find fun and it's great. But yeah, and so I think there's a difference there, and I think this applies to programming in that you can write a program that is just a simple bash script or something that moves a few files around and does something right, and it's quick, it's fast, it's like scripting. And then there's like production grade code that's going to go on a rocket or a spaceship or something, or a medical device, and that has a different level of requirements,
Yeah, it's right. It's right. Yeah.
and it's a different skill set.
Mm.
Because part of the skill is navigating the requirements. So that was something that I had on my list of things to talk about. You've done some medical stuff, right?
Yes, I have.
So,
I both made medical strength training equipment where we used a single board reel as the main part of the motor controller, and had that medical approved to the old European medical norm. But the software was approved to the 63 something like that norm. With module test and everything. And then I'm also working on some medical project now where we actually are doing some of the same. It's just a host application, but some of the same we need to go everything through to have it medical approved. There's a lot of documentation, but it's somehow fun to do all the testing and ensuring that it's working, and tracing all the requirements, ensuring that the requirements are fitting with the test and are fitting with the designs and everything. Yeah.
I have mixed feelings about some of that stuff because so I've been doing some stuff in an aerospace field right now, and it's highly regulated. And there's a side of me that totally gets the regulation side, right? Like there are lots of risks that could go wrong, but I feel like sometimes the things that they do to mitigate the risk don't actually mitigate the risk. I feel like a lot of it's like, in some ways, a lot of it's blame stuff. Like, oh, we want to know who to blame when it goes wrong, not like we're preventing it from going wrong. And like we want to cover our ass and we want to make sure nobody's going to sue us if something goes wrong. And there's a lot of that, and there's a lot of like, well, okay, yeah, this doesn't actually make things safer, but it makes the people in charge feel safer, and so therefore we're going to do it. And as an example, for one thing, like they had a thing where they had to print out all the LabVIEW code, right? And I'm like, well,
Wow.
why? Well, because the people who are reviewing it don't have LabVIEW on their computers to look at it. I'm like, okay, well, if they don't have LabVIEW, do they actually have they actually ever used LabVIEW? No. So
Mm.
why are they reviewing it, right? It's like what how does printing it out actually like maybe it might make sense to have that person sitting in a room in a code review and you walk through the code and you say, okay, here's what this piece is doing, here's what that piece is doing. Do you see any problems? Like that might actually add value. But handing them a stack of printouts and saying, here, go review it and sign a piece of paper saying you reviewed it, like, does that make anything any safer? My argument is no. That's just like busy paperwork.
Yeah, and my experience is that they are mostly asking about what they know a little about, and then go in details there, and then maybe all the complex things, all the really things matter is not they're not going so much in detail because they don't know so much about it. It's not always easy to understand what they're focusing on.
Yeah, well, I saw a really great presentation at one of the NI Connect. Well, actually, it was NI Week, so it was way a long time ago, by
Okay.
Albert DeWeese. He's a guy. He's done some biomedical stuff. He's a consultant, and he was talking about how sometimes like the requirements say one thing, and then by the time it gets interpreted by some corporate lawyers who are very risk averse, then all of a sudden we have to do these 20 things, but the requirements is no, you have to do this one thing. But in
Yeah,
order, and so we sometimes make things more complicated than they need to be. Like, for example, I think sometimes too, like you mentioned documentation, like sometimes the documentation, we're like, oh, we have to write all this stuff out by hand and blah, blah, blah. And sometimes you can like, no, let's just scrape the VI and pull off all the controls and indicators in the VI description and throw that in a document, and that's good enough, right?
yeah, yeah, yeah.
And so sometimes there are ways to meet these requirements that are like low burden. For example, like I had one where uh, they VI description has all these requirements and it has to be formatted a certain way and blah blah blah. And I just made a quick drop shortcut that like basically does it all for me. Like I write one little thing, I hit the quick drop shortcut, it pasted it into the thing with the correct formatting and whatever, and it takes me 2 seconds. But you know, other people spend a ton of time making sure all the formatting's correct. It's like, yeah, no, like
No,
that
no,
doesn't add value.
no, it should be automated. And if there is information two places, the same information, then if they wanted two places, it should be copied to these two places with some automized, definitely.
Yeah, yeah, as opposed to writing it in 2 places and then they're trying to keep them synchronized and like that. There's
Yeah, yeah. Then it goes wrong. Yeah, yeah. We did some with making a website with a VI block diagram and some description for the reviewers. And of course they need to know a little about LabVIEW, but if there's some descriptions, then I know it's then I think it's okay, and especially on the website in the HTML side, you can like press around and on the different uh, between the different VIs.
yeah.
And I was thinking about this new diff tool, and I have HTML page you can do with it as a diff tool. If I could actually use that, because there you can press on a sub VI and jump to that one, and so I will look into that if that could be used for such documentation too.
Well, I just thought of another very interesting parallel between what we're doing in climbing and what we do in coding. Uh, and that is in planning, right? So now I the pinnacle of planning, right, is I went on a trip many years ago, probably 20 years ago now. Yeah, 20 years ago now, to Alaska, and we went on a glacier and we spent a week in the wilderness. Okay. And at that point, anything you didn't bring with you, you didn't have, right? Like we got dropped off by a plane on a glacier and that was it. And the plane was coming a week later. And in that, the level of planning that we did was really high in terms of like we had to have exactly the right amount of fuel so we could melt enough water, right, to drink. And we had to figure all that out. But at the same time, like there's a saying something like no plan survives contact with the enemy. So you put all that effort into planning, you try to make it work, and certain things can't change, right? Like the plane's picking you up that day, that's it. Except that, hey, the plane gets delayed by the weather, it can't pick you up. We ended up having to wait an extra day. Or like, hey, you know, we were going to go from here to there, but it snowed 3 feet and we got stuck in our tent. Right. And so even with that level of planning and rigor, we still had problems. And almost every climbing trip I've been on, like we have a plan, but it almost never meets the plan. And I feel like in software, it's the same way, right? We start out, we have a plan, we think we know what we're doing, but then there are forces bigger than us that just dictate, like, hey, you can't do that.
Yeah, yeah, definitely. Yeah, for the big project or the big trips, it's planned as detailed as possible. But for small projects, small trips, weekend trip somewhere, long route or something like that, it's less planned. I also had such a trip where we have planned everything. It was in Kyrgyzstan. We were sent out with a helicopter to climb some new peaks, and we have discussed if it was 15 years ago if we should have a satellite phone with, and it was at that time where it was coming up. So somebody said we shouldn't have, and somebody said we should have. So therefore, we agreed. We invited a local as a base camp because we should be out there 2 weeks, so we shouldn't have all these things. A local woman with his child as a base camp supporter, and then we decided she could have a satellite phone. We was dropped up by the helicopter, and then when we packed out our stuff, we saw there was no gas, so we couldn't do anything up in the mountain. And we then found out that the satellite phone was also not working because it was too far out of that coverage. So yeah. Luckily, there came a Russian family walking by. We could talk to them. I think it was the only one walking in this area this summer. They was walking by directly when we came there and saved us, so we could have the helicopter out again with our gas. But yes, definitely, that was planned in detail this trip, but we didn't do as much as we expected because we were just so long out.
Well, I think you hit on something too. I think that the planning needs to correspond to the level of risk,
Exactly.
right? Because when you're going out somewhere and there's no support, that's risky. As an example, I'm about to go ice climbing in Cody, Wyoming. Every night I'm going to be back at the hotel. So like, if I forget something, I can go drive to the store and go pick it up. If there's a lot less risk there. Now when I go out, the days are long and I need to make sure when I leave the house I have everything I need for the day. But and also too, I think another thing that this we don't do in software well enough. I feel like in mountaineering, I am very willing to give up and bail, and knowing when to turn around is a very important skill. And I don't think we do that in software. I think a lot of software projects I've been on, they just double down. And to me, like there's a lot about about failure and accepting failure and knowing when to fail and when to come down and when to bail. And yeah, uh,
Yeah.
thought.
Yes, that's probably right. Of course, when you are bailing, you have always got somewhere up. You have done some. You maybe not reached the goal, but you have done some and learned something also for next time. But it's right then maybe in a software process, then step back and say, okay, we maybe cut some of it up. Say what is best building from here. That's right. That we are not good enough in saying, okay, we were out on the wrong track. We need to maybe take a few steps back and say what we have use of time. It's more learning time than everything else. Yeah.
Well, that brings up another point, and maybe you've run into this. I've had trips where I've bailed, and looking back on it afterwards, I look back and I'm like, yeah, that was 100% the right decision because things would have just went horribly. And then I've had ones where like we get up there, the clouds roll in, it looks bad. We come back down and we're sitting in the valley drinking beer and like everything's beautiful bluebird day. And I'm like, oh man, we could have been up there.
Yeah.
And the lesson I take away from that is that you can't judge the decision making process based on the outcome per se. You have to judge it based on what did you know at the time and what was a reasonable decision based on all the things you know at the time, right? Because also, like, you can make good decisions. Like, I had a friend, they were super experienced climbers, and his wife fell and landed at his feet and broke her neck, and that was it. And, like, like they didn't necessarily do anything wrong. I have another friend who was climbing something, and he did everything right. He got hit in the head with a rock and fell 50 feet and broke several vertebrae and was like, and he didn't do anything wrong either. And so in those cases, it's like, you know, they made good decisions. It just didn't turn out well. And I've seen people make bad decisions that also turned out well. And, it's
Hmm.
like, I don't know. Do you have any thoughts?
Of course, the risk if you're making a good decision, that then you are limited, decreasing the risk, but it will always be there in both ways. It will, yeah.
Yeah, well, that's something else too in climbing. Yeah, you can never get rid of the risk completely. right?
Mm.
Like you are, if you're 50 feet off the ground, gravity doesn't care, you're still 50 feet off the ground, right? It doesn't care how experienced you are, how prepared you are, or anything. You're still 50 feet off the ground. You could fall. And I feel like software is similar. Like it doesn't matter how much of a plan you have or whatever, you're still spending time and resources and energy and investing in this project. And there's a chance that it all goes wrong and you lose that investment.
Yeah,
Right?
yeah, of course. But when you are more experienced, you can also have an idea about what outcome can be. But then maybe also taking bigger projects or bigger risk, you can say. It's uh,
But it's also too, it's like a mental game in that, like I always used to say that one of the worst things that could happen is to succeed on your first mountain. Because I feel like it's good to actually fail the first time, just because it like sets you up. You don't get this idea that you're always going to succeed and everything's always going to go well. As an example, I'll pick on my sister a little bit. Uh, she went to a place that had a bunch of casinos and stuff, and she went. And the very first time she went, she won like a couple $100s. And she got it in her head that like, oh, I just need money. I just go to the casino. I go win more money. And it's like, no, 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 it doesn't work that way, right?
no, no, that's right. Yeah,
And that was like the worst thing that could happen to her, right? Not she's not like a gambling addict or anything. She's fine, but like she had it in her head that like, and then she went and lost a bunch of money. Then she's like, oh, okay, now I understand, right? But like that's like it's one of those things where like you need to be realistic about your expectations. And another interesting thought that just popped in my head, and maybe you've heard this. When I worked at Westinghouse, we were doing a research and development, and they had a saying something like, if a certain percentage of your projects don't fail, you're not doing research and development, right? Like if you're really doing cutting edge stuff, you're doing things where like we don't know if this is going to work or not. They're not all going to work out. It's kind of like an expected part of the game. But I feel like that's a different mindset though than other places. So like for example, LabVIEW is used in R&D testing, and I do a lot there, but people also do it in production testing. And if you're doing testing products coming off a product line, that shouldn't be R&D per se, right? Like you don't want those projects failing. Those should be projects that are like more cookie cutter, more like we know exactly what we're doing. We're just kind of putting it all together.
yeah, yeah. I actually think there is a little mindset different in the US and Denmark there. For example, entrepreneurs who are trying to build up companies. I know a guy who have tried to build up five, six different. It was in the fitness industry and biking industry, and he had failed five, six times. Then we had him employed, and there came some investors from US, and for many Danish, he was like he don't know how to run a business because he had failed so many times. And then came these investors, and they were like, "Oh, here's interesting. This guy here failed so many times. He will succeed next time." And now we have actually done a very good business. I have the feeling that especially in the entrepreneur business that you are better in um, saying a failure that's just a step to a new beginning than where we in Denmark is, oh yeah, he failed so many times so he don't know anything about it. And the public opinion is that the learning to have, it's just because you are bad. It's not that you are learning, and maybe you have learned from that to make a um, uh, better start up next time.
I think the question isn't so much failure, it's more about learning. And
Yeah,
I think failure helps learning, but it's not guaranteed. So like there's a couple sayings. One that pops in my head is like good judgment comes from experience. Experience comes from bad judgment. I don't know if you've heard that, but that's definitely one that we say a lot in rock climbing.
yeah, yeah, that's right. Yeah,
Out of a book I read recently, and it said something like experience isn't just the best teacher, it's the only teacher, but it doesn't always teach, or something like that. Just having right, and I think that goes to like Fab's thing of like, do you have 20 years of experience or do you have 1 year of experience 20 times? If that entrepreneur actually learned something every time he failed, right, or is he repeating the same mistakes? Because that's the other thing, right? Like if he built a business and it failed because of X, and then the next business, okay, he didn't fail because of X, but it failed because of something else. Well, he's learning and moving on. If it consistently every time he does it, it fails at the same thing, that for the
yeah,
same reason, that to me is a sign of not learning. And that's where I would be like, oh, okay, like stop beating your head against the wall. This isn't for you. Go do something else.
yeah, yeah, yeah. That's right. But it's still, and that when you're seen from outside, you're not necessarily seen, but yes, yeah.
Okay, let's talk about more LabVIEW based stuff. You mentioned FPGA, and I had just started doing some FPGA stuff recently. So when I started, my boss at Westinghouse bought me the LabVIEW training bundle or whatever, and I took the FPGA course, and it was great. But then I never actually really used it until recently, and then I had a chance to use it, and I quite liked it in the sense that I felt like I was getting closer to hardware and closer to like almost like designing circuits, which I've had Terry Stratatakis on, and he's mentioned that. So yeah, why don't you comment on FPGA?
Uh, my first will I had some experience with normal FPGA from my study, and I was this writing the HDL. My the other one in my group said that I couldn't understand how FPGA actually was working, because I was like wanted to have it sequential and stuff like that, and I can see now it was completely wrong what I did. Then actually when I really started with LabVIEW, I started with FPGA. I had done a little LabVIEW before, we can talk about that, but then when I really should do something, it was on FPGA, and then I directly saw it is so powerful. We built up in few weeks a complete new motor controller in FPGA. Had it running, started with such a PCI card and then card, and then had it to a single board Rio afterward, and just saw how powerful it is. And then I was like, okay, we had some FPGA, we also need some real-time application, and then also need some host. Um, and it is today. I'm using a lot of FPGA for my customers. If I need a counter, then if I use DAC counters, suddenly there's only like 4 I can use on the module. If I use the FPGA, then I have as many as I want. Configure a different. I can use the SPI, I squared C, all these things I can just add to the module. So it's really one of the reasons why I have stayed with with the LabVIEW. It is the FPGA part, and I really enjoy using it. Also, yeah. I tried to do some scripting of the how to provide to and from the FPGA, and it's not necessarily easy, but I have come some way, because on the FPGA you're always talking through the front panel, and when you have a little more complex, maybe a simulation part, then you have a lot of front panel items, and you get this very long list in read write mode. Try to do that a little bit more dynamic to change that. But definitely FPGA is, yeah.
Well, I
That's
want to
it.
talk about that a little bit. Going back to our previous metaphor with the carabiner and limiting risk. Uh, Definitely FPGA, I feel like the development is slightly risky in the sense that it takes a long time to compile. And so I want to try to minimize that. So I've tried to do lots of testing and simulation, but I haven't had good luck with a lot of the simulation on FPGA. Like, and maybe I'm not doing it right. I don't know. Have you had a lot of luck?
Often on the FPGA, I've tried to have like module, one module, and test that. So in this simulation, that's for engine, and there is an encoder. Then building that one, start building a module test around. You have some Hall centers coming in, and you need some position coming out. You need more or less what should come from each end. So from module, it's right with having the simulated I/O.
Yeah.
That's I have never done that. I have always like taken then take the module, and then if I have an I/O port, add in a conditional disable structure and put it to a global variable, so I can simulate it somewhere else, and then
Okay.
synchronize it. These built-in simulation I have never really used. Only if I should not test the I/O and only test something else, then it's nice to have it running on the
Yeah.
host computer, like it's running on the FPGA. But it's right, yeah.
Yeah, I mean, yeah, having just simple VIs that just have inputs, outputs, like that part's fine. But yeah, it's the IO and like if things have to happen in a certain order, and like the timing, I found that was the hardest part was simulating like the timing of stuff.
Yeah, yeah, yeah. But then I often take it down to a slower speed when I simulate. So when running on the host computer, it may be running with 1 millisecond, what is running or with 1 microsecond, or the tick count on the FPGA, then the simulation is taking longer time, but I'm sure that it's running with correct steps and not suddenly too long, too fast. Yeah. So
So I have a question, and I think I have an answer to it, but I'm also curious to hear yours. So if I'm thinking, why would you use an FPGA as opposed to using the real time system or Windows? I think of two things. I think of one, and I think you mentioned the speed, right? It's super fast. It executes at like the FPGA clock speed.
yeah.
Uh, and then well, actually, I think of three things. I think of speed, I think of parallelism, in that you can have multiple things going on in parallel that are completely independent. And then the last one I think of is robustness, in the sense that you deploy to the FPGA, there's no operating system that can crash or anything. It can't run out of memory. It's just there.
Yeah. It's deterministic when it's first running with this speed. There's not suddenly some kind of process going in and
Oh,
change it.
that's another one. Yeah, it's
It's just
deterministic.
running with this speed you have set it to run. And of course, always try to divide it up in a lot of separate loops, so there's no coupling between the different loops. So you're sure when this one is running, it's doing what it should. And for module wise, I think it's often easier on the FPGA because you just have some input output, then you have this loop doing one thing what it should do and not doing too much different. So you
Yeah.
but with the risk you talked about with long compile times, and then there come this risk that suddenly it can't compile,
Uh-huh.
and yeah, and it's always a risk in a FPGA project, and sometimes it's also a bug that you have put in a wrong mod. This module can't be in this slot. You can only have it in another slot. I have experienced that, and then I had this where I was then making a script to compile build it, because it was like failing every second, and then I changed it, then it was failing every fifth time, and so it's not really okay. Failing not, don't fail. So I had this script and I was like compiling it 800 times during this. Have just one machine standing and compile, and then I was changing something, and in the end found out that it was a bug in the CPU, that I should when I had plugged this module in this slot, it was just sometimes failing.
That's another interesting thing I've learned about FPGA builds, and correct me if I'm wrong, but they're not deterministic, right? So you can have an FPGA bit file, you can try to build it and it builds, and then if you try to build it again, you don't get the same binary output, and or it may not even build the second time, right?
Yeah, and that's both good and bad. It's of course difficult that you can have this, that it's maybe building, maybe not. But if you have something that is on the edge can build, then you can set up a pipeline saying, okay, I'm allowed to build 5 times, and if
Yeah.
just one of them pass, and then you can set it over, and then you are quite sure that it will pass during the night. If you have one of these that is on the edge, instead of need to spend a lot of time and find out is maybe so I think it makes sense that the compiler is doing some randomization every time.
Yeah. Well, I do feel like FPGA is one of those places where having some automation and some CI/CD type stuff going on is very useful. Just because like you don't want that compile thing running on your computer and sucking up your PC and making it unusable. You want it running somewhere else.
Yeah. You can also use the NI compile service, except it's often closed in organization I have experience, but else when I'm from my own office, I'm often using that.
Yeah, and but if you're in a situation where you can't use the NI one, they do have one that you can host, right? I think.
Yeah, that's right. I haven't really worked with that, but yes, it's right. You can also host your own.
Yeah, make your IT department earn their paycheck.
Yeah,
Send them off to
yeah,
go set that up if you can get them to do that. Um,
yeah.
so we should talk too. You wanted to mention advent of code, but we should talk about advent of code and learning new things.
Yes. I attended Advent of Code last year in 2025. as first time. And when I first start this, then I'm too competitive. I can't stop. But it was like, okay, I had a lot else to do, so it was early morning, late evening. I could work on that. So it really forced me to learn the quick drop shortcut, learned me to do fast programming, and I can make the hold the control down to make a bigger constant from my input and all these things, and learn as many quick drops as possible, because I could feel that it should just go fast, and I really felt afterward that it had improved my programming. Of course, I still need to stop and think, but this that when I first have something in my head, it should be done like this, then it's very fast, and I don't need to think so much and don't need to click so much when I do that. But it was very learnable, and I could see it was other thing. There was some problems that everybody had issues with. There was some linear programming, and that's okay, but LabVIEW had only linear programming with comma numbers, with doubles, and it should be done with integers if it should be past this one, and therefore it was difficult to do in LabVIEW. That was one task with that. But else it was interesting to see that what somebody think was very easy, it was not fitting my mind, but then there was some other task where I said, oh yeah, you can just use reentrant, reuse clone reentrant, and then do it very simple, some other, and so it was very learnable, and see how the other have done it. And try to learn from them, and also show what yourself are doing, so other can learn from the way you're programming. I can only recommend. It's taking some time, and it's but you maybe don't need to do everything.
Yeah. Well, yeah, so it is time consuming. They did shorten. They used to be 25 days, and now it's like 12.
Yeah. I'm happy it was only 12, because else that have been,
So yeah, in my experience this year, I wanted to do it. I wanted to teach myself JavaScript, and I did not. But it's a good way to learn new languages. It's
I
also
can
a good way to just hone your LabVIEW. Some of the stuff I've gotten out of it, lots of technical stuff, like about like various algorithms and optimizations, and a lot about regex. Regex is a big one for me on that, because parsing the input often requires some regex. I have a question for you though. Did you write any tests when you were doing that?
Actually not.
Okay.
No, I was actually not writing any test. No.
Good. Well, the
Yeah,
reason,
no,
yeah,
yeah,
I don't point that out to like try to shame you or anything. The reason I put that out though is because I like using those examples to teach people about TDD, because if you notice at the very beginning, they give you some simple examples that you can like build up. And I found for me, I thought that that made me go faster, because, yeah, it took longer to get started. But by the time I got to the point where I think the thing's done, the first try I run it and I get the right answer, and that's it almost every time. Sometimes there's some little thing that I miss, like, oh, I'm using a I-32 and I should be using an I-64 because it overflowed or something like that. But generally, the logic is like very sound by the time I get to running the final one.
yeah. But in principle, I would say it's the same that I was developing, seeing an answer, see that it is
You're
fitting as
running
what
it
I
as
was
you're
before.
doing it.
Yeah.
It's not
So
running.
I was not building the test framework around, but I was
Yeah.
like testing that, and what I found, especially with the first ones, uh, was that I was very sure when if it passed with the input they have done, they have showed me, then it was also passing the first part of the day. But the second part, there was always something that it was not necessary just because it was passing the input they will
Yeah.
come with.
They
Then it
missed
was not
something in the test.
yeah,
Yeah.
because there was some special cases down that you had to take care of.
I did run into that a few times the prior year. There were a few things where like the test case didn't cover all the edge cases. Uh,
Yeah, and I tried that in the later on to like try to read the input and see, okay, is there something that I haven't taken into account here? And I think it was it was helping. I didn't have the right output, but at least look at the input data with my eyes and see, okay, this one looks different if I try to calculate by hand, this input here is then helping.
Yeah, sometimes you do have to do the calculation by hand. And then another thing too I found is, part one versus part two. Sometimes having the test actually helped for part two because sometimes I could take my answer from part one and refactor it, and then I had the test to like just run to quickly confirm. But I mean, it's one of those things where like I could see the argument for like I don't want to write a test for this because it's like throwaway stuff. I'm not going to use like it's not like I'm building a system where it's going to keep going. But I will say one year, and I want to say it's like 2018, 2019. If you go back, they had you build a compiler over
Okay.
the entire 25 things. So you start like, oh, parse this string, then parse this string, and oh, here's a set of commands, and everyone built on the other one. And for that one, I did not write tests for that. But if I was to go back and do that again, I would write tests because everyone built upon the previous one. In that
Okay.
case, I feel like there was more value to the test. It's kind of like, I like doing test-driven development and all, but if I'm writing a simple bash script to move some files around, I probably don't need to write a test for that, right? Like I can, I might back up my files before I run the script, but then I run the script and it moves them or it doesn't. And if it doesn't, okay, like I figure it out.
Yeah.
Yeah. So there's definitely a pragmatic aspect to it, but I like using the advent of code to practice that because it's like a low risk, easy way, and it gives you good examples. And so anyway, yeah,
Yeah, it's definitely maybe something I will think about next time. This it was just see what
it's
it
your
is,
first time
try it
too.
out, and I learned this with a quick drop shortcut. I was taking this yours and Stefan's list and was trying to read through, so I could learn a little extra every day.
Yeah. Yeah. Well, that is definitely 100% Stefan's list. I just helped
Yeah,
distribute it. So
yeah,
I
I
don't want
know,
to take any credit.
but I would also put your name
That
on
is
because you distribute it.
that is an amazing list. It's got like 20 pages, or it's like way more comprehensive than anything NI's put out on the
Yeah,
shortcuts. So yeah,
yeah, really
I
okay.
think there's a link on my website, or you can get it from Stefan. But I would say that the two goals I have always for Avenue Code is have fun and learn something. So it sounds like mission accomplished. Uh,
Definitely, it was a little stressed sometimes because there was some competition and I didn't have a lot of things at work. I was also traveling, so it was early morning in the hotel, late evening in the hotel. But yeah, but definitely when it was finished, it was climbing this hard route. It's some of the same. It was stressful in the between, but then or long route. But then when you came up, it was you felt you have over.
yeah. There's definitely a competition aspect to it, which can be unhealthy, but
Yeah,
as long as it's in good fun. But keep in mind, if you are someone who's just joining and competing, you're competing with like Darren and others. So, like, there are
yeah,
some very sharp, very fast people on there. So, don't, I wouldn't go into it with, I'm going to be number one. And like, yeah. But also, too, like to your point, like the time zone thing is a problem because it releases at a certain time. And if in your time zone, it could be the middle of the night or could be some inconvenient time. And so that skews the results a bit too.
yeah. But then learn from seeing the solution from Darren how we have done it. Especially in the beginning, it was like, oh, that is simple and wow, and no wire crossing, and so it was really teaching me when I looked at my own a little more messy code. Uh,
Yeah. Well, also there's a second level to that, and that is once you get it to work and you pass the test and you're like, okay, great, I got the answer. Going back and optimizing some of those is quite interesting too, because so a lot of those problems, there's an optimal way to do it that finishes in a reasonable time, and there's a brute force that takes like 10 minutes to run. And sometimes you can get the right answer with the 10-minute solution. And it's like,
yeah,
okay, that's great. But then if you really want to learn, go look at some of the other solutions and look at some of the optimizations that they did. The good one for that, I don't know if you did the Wordle thing that they did. For Summer of LabVIEW, they did like a Wordle challenge. And that opened my eyes to optimization a lot. That was like, whoa.
yeah. Actually, I was a little too late for Summer of Blackview for that one. I did the two after the game
Hard one?
and the race car.
Yeah.
But I was too late for that, and it was like stopped, and I couldn't. I think they stopped that you were not allowed to upload anymore. So
Okay.
like, yeah, I didn't. Yeah, but definitely I could see that was very, very interesting.
Yeah, yeah, it might be worth. I think they have a forum. You can go look on the forum and look at some of the optimizations. Because I learned a lot about string parsing and what's fast and not, and then manipulating arrays and like there was something about like if you can make a string into a byte array, it's like way faster than manipulating it as a string, which I found very.
Okay. Yeah. Yeah. Strange. Oh yeah. Yes.
All right. A few other things that we should talk about. Going back to climbing again, because why not? You mentioned the library community and finding community. I find like climbing, I feel like also has a very welcoming community in general.
Definitely. Yes. Yes. Definitely. It. And somehow I feel it have changed, but maybe it's just because I'm old and not so much in the community anymore. I felt I actually the reason just out of university I decided to buy a car because then I was the one having a car and then it was easy to find a climbing partner. Then I just wrote on the forum, I have a car. Do anybody wanna go climbing this weekend? And then there was always somebody that was up for it. I think it's a little more. People have their own partners, and it's when I write out, it's still the old ones are coming are writing. It's not so much I'm doing it anymore with family and stuff like that. But what I can see is it's more the old ones that are there, where the newer ones they have like their partners and their own car and drive out and do something. So in general, I think it's very open, and always when you meet some climbers on the route, you're always talking to them and get some good ideas, get some good betas for the different parts. Definitely, it's open in that way, and yeah, it is probably some of the same. It was also one of the reasons I stayed in climbing. Definitely, yeah.
Yeah, something I found in climbing is that when I started, it was kind of this countercultural thing. Like it wasn't very mainstream. And now between climbing gyms and Alex Honnold and all the publicity, it's become much more popular and things have gotten much more crowded.
Yeah,
Um,
yeah,
the,
definitely.
the one thing I noticed, like I go to places like Ure, which is this big ice climbing place, and the first time I went there was overwhelming because it's just like super crowded, like a rope every 3 feet and like people everywhere. And what I realized from that, like first it was off-putting, but then I realized like all of these people were actually like very good people. Like I enjoyed hanging around with them and talking to them, and they were good. It was just the fact that there were just so many of them that kind of. But once I was like got out, stopped focusing on the crowd and focused on like the people next to me, I was like, oh yeah, they're cool. So
Yeah,
it,
yeah,
it helped. And I mean, there are some advantages to it being more mainstream. It's easier to find gear and buy stuff, and there's more choices, and companies are investing in newer and better gear. So if climbing was still this like countercultural thing, we might not have as much new gear and nice things. And there's more information out there about like places to go, and there's more guidebooks, and so yeah, it's I guess there's not much point in fighting it. It is what it is. I think it's just more of like you want to like focus on what are the good things, and maybe that's like bringing it back to coding. Like maybe AI is making coding more accessible, and maybe that causes some problems, but maybe there's also some good things in there. I don't know.
yeah, yeah. That could be. Yeah, I
Yeah.
haven't thought that way, but yeah, maybe.
Yeah. Um, a couple of other things on my list. You mentioned doing PLCs and structured programming. You want to talk about that a little bit?
Yes, I learned that recently. I I got into to a company. They just wanted to support on some old production machines. Well, yeah, that was running some old lab Windows CVI on it, only compiled, so I couldn't see what is the code, and it kept giving problems. And it is a production machine, some yeah, moving stuff and stuff like that. And then I said, okay, I don't think we can get it to work very well, so maybe it's better to change the control. And they were into that. And and for such machine, I could see a single board Rio. If I should have that with a motor controller, it would be too expensive, and it was not the optimal to use. So therefore, I went with a combination with LabVIEW and some PLC, and therefore I needed to learn the structured text even in text, I of course try to have as little in the structured text part, and then everything in that view, everything more complex. Yeah, it was a learning about how I've never really used PLCs before, so yeah, it was probably just as normal programming, but this that you're running the whole program, every tick you're running, it's maybe a little like the FPGA that you're running the whole program every tick, and then had different sequences you can say that you are communicating between. But it have been a learning experience. It had taken much longer time, especially to get the motor to work stable that I had expected. But I think it's starting to be good, and they're happy for the results, definitely.
Yeah, I have a friend who's really into using PLCs, and he's used them for some stuff. I think he had something where they had, I'm probably going to butcher this, but it was something about they had some kind of pressurized tank that they had to keep the pressure in, and like just like hooked up a couple pressure regulators and a few things, and it was much easier to do that in with a PLC. And it was much, I mean, it's much less cost, right? I mean, it's basically the robustness of a serial, but without all the brains and capacity as far
Yeah,
as.
yeah. It would have been much easier if I could have something a FPGA with a mode controller a module or something like that. For me, it would have been much easier, faster to get something running stable. But I will definitely take it in next time. Think about if I should use that such one instead. It have been a learning, and now I have this extra tool I can use and know the pros and cons. So next time it will be easier to get a good result.
Yeah, well, I think that ties in nicely to the next thing, which is I like to ask people about experiments that they've tried, and you had one that you wanted to talk about that dealt with the economics of building.
Yes, as I have mentioned, yeah, it was actually just after university I was employed in a small startup company, uh, and then the finance crisis came and it went down. But we were making a indoor cycling bike, and we had a patented motor with a gearbox inside, very smart. And then the finance crisis came, the investors say, okay, the world will be short of cash, as I said, and they didn't want to invest more. So it went down, and then I continued with my former boss, and then we partnered up, two persons, and together with a German company, tried to take this motor and develop it for medical strength training equipment motorized. So instead of a weight stack, you have electrical motor. In
Mhm.
that way, you can do the much more precise the training and much more variation. In a weight stack, it's always when you're pressing, it's always weighting 30 kilo. You can do something with a cam, but in principle, it's always weighting 30 kilo. With a motor, you can change the weight, you can change the speed over time, over when you use it. And we found out we should have a new motor controller. We started with LabVIEW FPGA. We had one in and helped making the first one on a PCI card,
Mhm.
this one, and then we could see it very fast get up and running, and we continued it with a single board Rio,
Mhm.
and it was very nice because that was mostly focused about getting everything to work nice. The programming, the development was quite of course it was something, but it was quite simple. It was mostly you could focus on the application, and then when we continued developing, we didn't have so much money for development, and I thought the equipment would cost 13, maybe 15,000 euro, and such a single board Rio is 800-900 euros or so. Compared to what it cost, it's such a little part, so it makes sense to continue. And the other amount was, yeah, okay with that. But the project ended up dying because the cost price was too high. I wasn't aware about this. When you take this 13,000, then you need something for the distributor, maybe 1/3. Then you need something for the salespeople. Then you need something, and then you suddenly only have like 20 or 30% back to actually the cost price for the machine. So therefore, it was also that project that got medical approved. We got it to a medical market, but still the cost price was too high, so we couldn't really have success. Nobody was earning money, and it have really followed my since this that. If I go into a project, I need to see that there is money in it for every partners. It's if I can see I can earn something on a project go into, but the customer, it will not be a project where they are earning a lot. It will never be a good project because they are never so eager to continue this project. So I'm always trying to see that there should be money in it for everybody. Because then everybody is eager to get it to work and really push it. It was my learning experience from that. It should be said that we, since that in this company, have made a new version with a small ST microcontroller MCU with some C code, and it is a very good project now. It's also medical. It's about to be medical approved, but we have used so much time to everything around this C code. Every time you should have some information streamed out from the FPGA, from the you could just also everything you had on the real-time processor, you could just add on a graph, and then you had the graph. Now we need to program something special to get exactly this signal out, so we can get a graph of that. So there was much more around getting it to work. It took longer time for programmer to get it to work, but then it's cheaper in production, and that is a very important part I have learned.
Yeah, I feel like I try to encourage library developers to better understand economics and business in general. And I think the thing that I see a lot is it's important to understand the trade-offs in development versus mass production. Right. So if you're building something that's a one-off thing, like for example, I worked at Westinghouse and we built these bespoke systems. Hardware cost is the small part of that because you're only buying the hardware once and you've got all these engineering hours. So if spending extra money on the hardware save you a bunch of engineering hours, you come out ahead. But when you mass produce something, the hardware cost, every single unit has to ship with one of those pieces of hardware. So if you pick a really expensive piece of hardware, then every time you build one, that adds to the cost. Versus you buy cheaper hardware, you spend more time on engineering, but that engineering cost gets divided amongst however many units you make.
Yeah,
So
definitely.
there's definitely a trade-off there. And so it's important understanding like where you are on that curve. Like, is this a one-off? Or are we making like three or four of them? Or are we making 1,000 of them? In which case, then hardware cost becomes much, much more important.
Yeah,
And saving a
yeah,
few cents on a particular piece of hardware spread across all those things is definitely worth looking into. So
yeah. It is. It's a really. I only was technical at that time, and I really learned economics is always an important part that I
yeah.
need to look at.
Well, I think if you don't understand that as a developer, you tend to make choices based on your own convenience. You're like, oh, well, this is easier for me to spend a bunch of extra money on this hardware. And again, if it's a one-off, it's totally worth it. If it's the mass production scenario, that's not the main cost of the thing. So, and I think part of that goes to just understanding the company and the company's goals and your manager and your manager's goals and stuff, and not just making decisions based on what's best for you right now. Because like I mean, if you want to get promoted and stuff, you got to understand what your manager's getting graded on and try to figure out how you fit into that.
Yeah, yeah.
And so yeah. Well, thanks for coming on. I really enjoyed it. I enjoyed the climbing talk. I don't get to talk about climbing a lot on the podcast, so it's kind of
Yeah, I liked it too.
yeah. And definitely climbing is one of those things that, like I said, and I think it comes out in the podcast that there's a lot of lessons that you can learn from that I think can apply to all kinds of things. And so I think it's a good hobby. I like it.
Yeah, yeah, definitely. I
All
look
right.
forward to more time for it, but yes,
Yeah, yeah. I definitely having kids slows down the climbing. So
exactly. Yeah.
trade-offs.
But there's also some good about that, then definitely. So I will not trade it in.
Yeah, yeah. Well, I'm definitely training up my future rope guns, so they're gonna lead me up all kinds of hard stuff.
Yeah, exactly.
Cool.
Yeah.
Thank you. Woohoo.
Yeah, thank
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast